Here are the objectives for section 1.2. Solve linear equations in one variable. Solve linear equations containing fractions. Solve rational equations with variables in the denominators. Recognize identities, conditional equations, and inconsistent equations. And solve applied problems using mathematical models. It's going to say that a lot. In a lot of our objectives, it's going to say solve applied problems using mathematical models. What does that mean? It's word problems. It's word problems. Okay, that's exactly what it is. So sometimes I'll give you a word problem to solve. Most of the time, it's if you can figure out that, you guys are pretty dang good at solving word problems. So it's all the stuff we just talked about, but in a word problem. Got it? Okay. Solving linear equations in one variable. Are you ready for this? I hope so too. 2x plus 5 equals 9. Can you solve that? So technically, how many possible first steps are there? I can see 3. Yes. What do you think we probably should do first? What makes the problem the easiest? Subtracting the 5 from both sides, right? That makes the problem the easiest. Could we divide by 2 first? You could. It's not the easiest, right? 9 minus 5? 4. Next step. X equals 2. Last step. Check it. 2 times 2. 4 plus 5. 9. Does 9 equal 9? Then that's the right answer. Got it? Any questions? Okay. The next objective talked about solving equations with fractions. Okay. 2x plus 5 over 3 equals 9 over 6. So we could get a common denominator, but wouldn't we rather get rid of the denominator? Okay, what could we multiply both sides of the equation by to get rid of the denominator? 6. If I multiply both sides of the equation by 6, what happens to this? It simplifies to 1, right? What happens to this? Simplifies to 2. So I have 2 times that equals that, right? Because this is simplified to 1. That's a 1, that's a 2. So on the left-hand side of the equation, what do I end up with? 4x plus 10. Everybody see where I got that? I just distributed this 2 to each term on that side. And what do I end up on the right-hand side? 9. Now it's just the same as the problem above. Subtract 10 from both sides. 4x equals negative 1. Dividing both sides by 4 gives me x equals negative 1/4. Now is this as easy to check? Okay, so it's negative 1/4 times 2. Negative 1/2. Negative 1/2 plus 5. 4.5 over 3 equals 9 over 6. $1.5 equals 1.5. So yes, it's correct. Okay, so that's my answer. Got it okay? Alright, there was some vocabulary in the objectives that I don't think we've talked about before. Solving rational equations with variables in the denominators. We need to do some of those, don't we? Okay, then we'll get to the vocabulary that you don't know yet. 4 over x equals 5 over 2x plus 3. Again, do we want to get a common denominator or do we want to get rid of the denominators? So what would be the common denominator if I got one? Close. 2x. So I'm going to multiply each term by 2x to simplify my denominator. So that's gone. What do I have left right here? 8 That's gone. What do I have left right there? 5. We already have 8. And then what happens right here? 6x. How do I solve that? Subtract 5. 3 equals 6x. X equals? Again, is this as easy to check? 4 over 1/2. If I divide it by a half, it's the same thing as multiplying by its reciprocal. So 8, right? 4 divided by a half is 8. 8 equals, what's 2 times a half? 1, so 5 plus 3. Isn't that the right answer? Yeah? Okay. So, what is the solution set to this problem? What's the solution set? What's the set of all answers that's a solution to this problem? 1/2. Okay? We never wrote the answer like this. We always wrote the answer like this. But if it asks you for the solution set, this is a solution set. Okay? Does that make sense? Okay. We've done these way more recently than the others, but these were harder. So it's where we're going over a couple more of them than the others. Okay? Again, getting rid of the denominator, we have to figure out what our common denominator would be. What do you notice about this? We could factor it x plus 5, x minus 5, right? Okay. So what's our common denominator? X plus 5, x minus 5, right? So if I multiply everything by x plus 5, x minus 5, what happens to the first fraction? Get rid of the x plus 5. So what we have left is 4 times x minus 5. I know we could simplify that, but let's just get it written down first. Okay? What happens with my second fraction? X minus 5's 2 times x plus 5. What happens to the last part? Simplifies all the way, right? Oh, I forgot to close my parentheses, sorry. Equals 32. But once again, it's just as easy as a problem as the beginning, right? So distribute here and here. 4x minus 20. Distribute here and here. Plus 2x plus 10 equals 32. Combining our like terms gives me 6x minus 10 equals 32. Adding 10 gives me 6x equals 42. X equals 7. So 4 over 12 plus 2 over 2 equals 32 over 49 minus 25. Well, 4 over 12 is the same thing as 1/3, right? 2 over 2 is the same thing as 1. What's 49 minus 25? 24. So I have 32 over 24. Those both simplify by 8. So that would be 4 over 3. Is 1/3 plus 1 equal 4 over 3? Then that is the correct answer. I'm so good at math. Thank you. I've been practicing. Okay, let's talk about the wording in the objectives that we haven't talked about yet. Okay, recognizing identities, conditional equations, and inconsistent equations. Okay? So let's talk about identities first. Identities. Okay, yes, identities. Identities are something like this. X plus 3 equals x plus 2 plus 1. What's the right-hand side the same as? X plus 3. Does x plus 3 equal x plus 3? That would be exactly right, right? X plus 3 is equals x plus 3. That's an identity. Okay? A conditional statement looks like this. 2x plus 3 equals 17. Well, if I subtract 3, I get 2x equals 14 and x equals 7. This is the condition that solves this equation. Inconsistent is the last one. This statement is inconsistent. Why? What value of x will make this true? Nothing, right? In fact, if I try to solve it, I get this. 0 equals 7. Will 0 ever equal 7? No, then this is an inconsistent statement. Okay? Do you have any questions about any of these objectives that we talked about today? You got it? Okay. That's section 1.2.